Hello guys, my name is Arnau Jorda and I'm presenting nothing but I'm going to be explaining header files and classes today. So basically what a header file is and most principally what a class is, since C++ in its nature simply is object-oriented programming language, it means that it has objects inside. So what a class is basically an object, and you can create classes to your own benefit, to make things and to make programming easier, but you would have to make more files to make the code cleaner, but it just makes the time and processing time faster, and it also makes coding simpler in the future if you make header files that can aid you. So here in this test CPP, we're going to include iostream.h like always, then void main. So this is the first instance of a class that you're going to learn. Now the structure of a class begins with saying class.
The keyword class?
The keyword class, yeah. And then you name your class. So for now, let's name it A. And with classes, unlike with functions, you need to put a semicolon when you end the braces. That's just syntax with C++. And with good coding practice, you can put public, colon, private, colon. Now what public and private do, public member functions are things that the user, which is you, can access, and private functions are things that the user can access, but it's what the class uses to give what the user needs. So in a class, you can create functions. So let's make a simple function called int sum, or int add, better. And let's put in the parameters int num1, int num2. And you just put a semicolon there, and then that would be the end of your class. That would be naming your class. And now this is basically, the class is telling what the preprocessor, what functions you want to declare. So I'm declaring add int num1, int2. So the preprocessor knows I'm going to be using that. So think of this as declaring a function, and think of this next part as defining a function. You would go a. Well, firstly, you would have to put the number value there, and then you put a colon add int number1 int number2. And inside these brackets you put what you want to do with it. So you would return num1 plus num2. And now whenever you're in your main, if you call add and you put in 3 and 5, let's set that equal to an integer. Let's call it number, and then print out number. What we would get is 3 plus 5, which is 8. Now let me just make sure this is good. This is good. Now let me just make sure that this is above the main, so that it knows what the classes are. Now let's see if this runs. Add undeclared identifier. Where would that be? In 19, this is 19. Okay, so a undeclared identifier. Oh yeah, I forgot to say that whenever you're making a class, you want to initialize it. So when you're declaring add, you have to initialize the class A first. So you say A, and let's call it math. So then you can set int number to math.add. See if that works. Missing before constant. And it prints out 8. Let me just make that better for you guys to see. And it prints out 8.
Let me just stop you right here now, real quickly.
All right.
Close that window.
Close this one?
Yeah. Very, very good introduction to classes.
All right.
The idea behind a class is to create an object of the class that uses the functions and the variables that are associated with that class. So basically what Arnau did was he actually created a class called A, okay? Here's the name of the class. But for this class A, he went ahead, this is the name of the class, okay? Every object that you create in this class has to have this return type, right?
Yeah.
This is the name of the object. This is the object of class A.
Right. And that's how you initialize the class.
Okay? That anytime you want to use a function, okay, and this is a function right here. This is a function of the class. This is a function of class A. Okay? If you want to use this function called add, you need to create an object of the class and then use the dot notation. Use this dot operator, okay, to invoke the function. Okay? So you've got your object, and then I can create another object, okay? You can create as many objects as you want with classes in C++. Supposing I want to create a class called myNumber, okay? So you would do something like this. You would say A, myNumber, okay?
Yeah.
And then, semicolon, right? And then if you want to associate a sum of two ints with my number, you could say something like myNumber dot add, okay, which is the name of the function that he created inside the class, and then you could go ahead and put two ints here, like int x, int y.
Right.
Okay? So it lets you basically create objects that are more complex than the objects that you have now. What are some of the objects that you have now? Well, you have an int,
Yeah.
you have a double, you have an AP string, you have a Boolean. Well, what if you want a Gulliver student data type? What if you want something of type Gulliver student? Well, what does a Gulliver student, what's the property of an int? It's basically a whole number or the negative of the whole number, right? What's the property of a double? Well, it's got a mantissa and it's got an exponent, right? Because a double stores a real number. Okay, what's the property of a Boolean? It only stores one of two values, true or false. Well, what is the property of a Gulliver student data type? Well, what are some of the things that you can associate with a Gulliver student object? An ID number, a GPA, a grade, a first name, a last name, an address. You can create an object of the Gulliver student class. Student James Britt. And then if you want to associate different fields with that object of that class, you can do it. You can associate with it as many fields as you want. So that's one of the reasons behind doing classes, okay? Okay, continue, Arnau.
Could I add something?
Fine,
Yeah.
sure. You can erase that if you want.
No, it's good. But the thing is, when you're creating objects, I just wanted to point out, it's when you're creating an object, you can create as many objects as you want. So let me go ahead and erase this, just because it's in the way.
Yeah, sure.
Yeah.
Just make a big circle and then just...
Yeah.
or not.
So, when you were declaring an object of the class, like math, you can declare multiple things. So you can declare that, you can declare this, you can do anything. And the good thing about that is that if you wanted to, if you had a class that used, for instance, strings, and you wanted different people with different names, you could say A, Arnau, A, Alaz, or whatever, how you spell it, and then A, James. And you can do different types of things with that. And that's a good thing with classes. It's very open to how many you want, especially when you include vectors with the C++ syntax.
Now explain to us header files.
All right. So what a header file is
Oh wait, question. Alas.
You see how it says class A and then there's an int A : add?
int
add.
No, not that one.
This
yeah,
one.
That one right there. Why is it? Wasn't it a class? It's not an int, right?
No. Here's
No.
what's going on. Here's what's going on.
Yeah.
Here's what's going on. You're prototyping a function here. You're basically telling the compiler that inside of this class is a public function. Or I can actually use the word method at this point because you guys are all, hopefully, most of you guys are going to Java, okay? But basically allows what you're telling the compiler is, my intention is to create a function or method that's going to do something, okay? But I'm declaring it here. And I want to put it under public because I want to be able to use it outside of the class. One of the nice things about a class is if you create an object outside of the class, you can access the public methods of the class outside of the class. If you were to have created a method under here, if you had put this here under private, you wouldn't be able to create an object outside of this file and then access that method add. Okay? So what I'm doing is this entire thing from here to here is my code for my class, right? This is the declaration, my intent to create a method or function. This is the actual function itself. Okay? Notice the different syntax. I'm using 2 colons here. Okay? This is a very simple function. It just takes in two
parameters.
You pass it 2 arguments here. Here are the 2 arguments that you pass here. Okay? These are the 2 arguments. But by the way, guys, this code right here, this code could have been outside of this entire file. You could have put it in another file and still have accessed this function here because this function is public. Public means that you can access it outside.
But it has to be in like the same folder or something, right?
It would help if it were, correct.
Yeah.
Like in Java, you're going to create different Java files, but all of those Java files I have kids put in the same folder. And even though you're communicating with different objects in different files, the .java files, as long as the methods are public, you'll be able to create an object of that particular Java, that class, and you'll be able to do something to that object as long as that method that you're invoking is public. Okay? So, pretend like this right here is not even in this file. Okay? Test.cpp. Pretend this is in another, like tester.cpp. You can actually still do the math. You can actually still add 3 and 5, even though this object math is of type A, which is located in a different .cpp file. Okay? All because it's public. If it were private, you would get an error. Okay? These are your visibility. There's actually three major ones when it comes to visibility. There's public, there's private, and then there's protected.
Yeah.
Protected only occurs if you have a subclass that's extending a superclass.
Yeah.
And we're going to talk about that later, but there are smaller classes that actually become more versatile, become bigger, because they extend another class. So let's say that you have a subclass, Robot A. And Robot A, that class, Robot A, has the ability to create an object of a certain robot of a certain company, call it company A or whatever. Robot model A. Well, that robot model A may want to use the same type of things that most robots use, okay? Like maybe the robot arm may want to rotate along a z-axis and may want to grab something, okay? This motion here and grabbing may be similar for robot B, C, and D, but you don't have to do the code for rotating the arm and grabbing something. You don't have to do it in the class for robot A or B or C. You can create a superclass, and then if you extend, robot A extends that superclass, now it'll call on those functions that allow robot A and B to do that because it's extending that superclass.
So you're talking about inheritance?
I'm talking about inheritance. Very good. Okay, I'm talking about how small pieces of code that you do now can communicate with larger, more established pieces of code that have been done by the C++ community or the Java developer community. That's what you're going to be doing as programmers. You're not going to be doing everything from scratch. You're going to be taking your code and kind of like extending other classes, and then all of a sudden your code now will have all of these different features, right? You know, maybe your calculator, you know, supposing you want to turn it into a scientific calculator, well, all you may have to do is just extend this class that'll have these different methods that you'll be able to access that are considered more scientific than what you have to do in your calculator. Okay. All right, go ahead and continue on.
Alright. So now that we know how to make classes and declare classes and all the good stuff inside your main CPP file, I'm going to teach you how to make a header file and how to use it to your advantage. Now, a header file is better because you basically have less space inside your main file. You always want to have less space inside your main file. So let's call this a.h, and let's call this a.cpp. Alright, so now in our main, what we're going to do, we're going to delete this iostream.h, and we're going to put a.h. Now, when you go to a.h, the file, which should be here, alright, when you're firstly creating a header file, you always start with the Preprocessor Directive, not include, but if and def, which stands short for if not defined. And you want to do underscore underscore the name of the class, A. It's better to do it in capital letters, underscore dot h underscore underscore. If the header file A dot h is not defined, go ahead and define underscore A underscore h. And then at the end of every class, or every header file better, you have to put end if. And it's always better to leave a comment in saying what you're ending. And that's the main structure of a header file. So now let's go back to our main test CPP, and let's go ahead and grab this and put this in a.h. Now, what Mr. Morrell was talking about in inheritance, what it basically does, a header file, when you declare it inside your main main CPP, the header file will include all the preprocessor directives that it has inside itself. So say you include iostream.h in here, it would be irrelevant, or better said, redundant to include iostream.h here, because if you're including a.h, it's already
Automatically
included.
includes iostream.
Exactly. So now, since that's done, this is the main thing for a header file. So you would have all this, and then let's take this. Now for a.cpp, think of a.h as your declaration of your member functions or all that, and then think of a.cpp as the definition. So in a.cpp, you would have to include a.h, and notice that I'm using quotation marks. You have to use quotation marks when you're using your own header files. You cannot use these, the greater or less than symbols, because then you'll get an error. So now that's that, and this should be good. Int a, return number. That should link with this. That should be good. Alright. Now let's see if this works. Six errors. A, undeclared identifier. Syntax missing before identifier. Alright. So then you would have to do this, add number. Int a is probably, yeah, that's right. Alright, I forgot, I thought we were doing a header file inside the main. Whenever you're doing a header file inside, or better said outside of the testing CPP, you have to create what's called a constructor. Now what a constructor looks like is simply this, and then a destructor is tilde with the same class name. And then you can make an overload constructor if you wanted to. You can make int number or whatever, all that. And what these do, a constructor constructs the class inside test CPP. So say you wanted to have an int pato, and you wanted to set it equal to 12 before you call class. In your constructor, you would do that. So let's go ahead and go to our CPP file and create our constructor. Now constructor looks like this. You would do a parentheses, and there's our constructor. And while we're here, let's create our destructor. Alright, so in our constructor, if we wanted to make pato equal to 12 before we did anything, you would do that, semicolon, and that would be that. But if you don't want to include anything or do anything with the constructors, you don't have to. But it is necessary that it is there when you're doing a header file that's outside of the main CPP. So now we have our constructor, our destructor. Our destructor destroys the header file when you're done with it, or else you'll have memory leaks, and it'll slowly destroy the computer if you have memory leaks, especially with a lot of header files. With big programs such as games, you don't want to have memory leaks, because that's the main reason why all these game companies have dynamic memory allocation programmers, simply just to prevent memory leaks. So now that should all be good. Now it would return this. 6 errors still. Undeclared identifier. Save this. It's, where are the files anyways?
Temp, if I'm not mistaken, see temp.
Public void math.add public int. Alright. So this is saying that
That's
That's actually a linking error, that's not a compile error.
Yeah, it's a linking error. So it has to deal with where the files are.
Yeah,
Yeah, so where are the files?
I think that's the problem. One file is in one folder and the other file is in two other folders.
Would it be in this one? No, I don't think so.
Look at C temp.
C temp, where's that?
Yeah, let me see. Hold on.
All right.
1 minute.
All right, now we're back. And what we were having a problem with was a linking error. And what a linking error is basically the computer couldn't find the file that it was looking for. So if you see in our test.cpp, we included a.h, and this test.cpp, basically the computer was telling it to look for a.h.
inside of the folder where the test.cpp was.
Exactly.
But none of those, not all of those three files were in the same place.
Exactly. So we put them inside a folder called Arnau, and we put them all together so that there would be no linking errors. So if we compile it now, there should be no errors. Still 4 errors.
Close Visual Studio.
All right.
Double click on test.cpp. Okay, now try to compile it. Try to debug it first.
Debug it.
See, it's a linking error.
So when you debug it, so when it's built.
Hit F4.
So what would the link? It is a linking error.
Yeah, I may have to install the that part of the Visual Studio.
So is that the problem?
Yeah, it might be.
All right.
So just quickly summarize, Arnau, why you needed to do the 3 files.
All right.
Just quickly, just real briefly.
All right.
Just a quick summary of .h, .cpp, and then the main or the tester.
All right. So .h is where you're declaring your class. A.cpp is the definition of what the functions inside your class do.
Okay.
And then test.cpp, or whatever you want to call it, uses the functions that you declared in a.h and a.cpp to your advantage. So we used add, but linking error. So.
Okay. All right. Thank you. Yes. Question.
No.
Oh,
No
okay.
question. Questions, comments, guys?
No.
Okay. Arnau, thank you. Hit Alt P for me.
All right.